Hello guys and welcome back to my YouTube channel. Today we will be discussing BGP. Alright, let's dive in, okay? So what BGP is, it's an exterior routing protocol or exterior gateway protocol that is used to exchange routing information across different autonomous systems. And we'll actually dive into what an autonomous system is later in the slides, okay? And it's over the internet. It uses TCP port 179 and uses path vector logic to advertise its routes and prevent loops. It is the only exterior gateway routing protocol, actually, and the only path vector routing protocol as well. We have BGP to exchange information between different autonomous systems on the internet, ensuring end-to-end connectivity. It is primarily used by ISPs and large organizations with multi-home networks to manage traffic flows, ensuring routing across the globe, basically, from country to country. All right, and what an autonomous system is, it's basically a group of devices running the same routing policy or routing protocol, right? For example, you can think of an autonomous system like a country speaking a certain language. For example, Haiti, they speak specifically Creole. You can say Haiti is an autonomous system speaking Creole, right? And Mexico is an autonomous system speaking Spanish. Jamaica is an autonomous system speaking patois, right? So it's basically a area that runs a specific routing policy or a routing protocol. We can call it a language, right? And it's identified by a unique autonomous system number. And autonomous systems helps BGP manage routing protocols between organizations and ISPs, right? And BGP uses autonomous numbers to prevent loops and choose traffic paths. And this is an example of an autonomous system or BGP being used, right? This could be Haiti, Jamaica, Mexico, and then this could be another country like France, Spain, things like that, right? Running a specific routing protocol and BGP somewhat being like a translator, allowing them to communicate across a large area of distance, right? And there's two types of BGP, external BGP and internal BGP. So internal BGP allows devices to communicate within a single autonomous system. For example, like basically OSPF area, right? It allows it to communicate within a single autonomous system or a single country running one language, right? It uses a full mesh topology or route reflectors for scalability, and eBGP allows to communicate across countries or across long distances across different autonomous systems, right? And then let's actually configure BGP. So this is basically the commands that you need. I actually set up a lab a little earlier before I started the video, and this is pretty much it, right? So these are all configured. We'll just have to configure BGP on it, right? And just to show you, show run. So nothing configured, no BGP, nothing, right? So let's actually go into global config mode. And then it's basically like OSPF, right? So just router, BGP, and then look, you question mark, and this is the autonomous system number. The thing about configuring it is you can't use you can't do the same thing as OSPF where you could choose just a random process ID. It has to be the autonomous system number, and you can see that here, right? Because if you choose one on here and then the same one here, it won't work. It will just think it's connecting to itself, and it just won't work at all, right? So router BGP followed by the ASN or autonomous system number. We'll do 65001, and then we'll do the command is neighbor, and then the syntax for it is the neighbor address. So not this one, but the address here configured on router 0. And I'm pretty sure it should be, let me actually, 1, it should be 2, 1, 1, and 2, right? Whoops. Right, so it's going to be the IP address of this interface on the router that it's directly connected to, right? So we'll put 11.11, not 1.2, and then remote autonomous system, and then you have to put the ASN of this autonomous system that you're trying to connect to, right? And let me just show you as well, AS of remote neighbor. So the neighbor interface, the autonomous system that it resides in, right? And it resides in 65000. So we'll do that. And then now that it's established that connection, we'll have to configure this side first. Excuse me, yeah, this side first, and then it will establish. But after that, we'll have to actually advertise everything that's here, as well as the loopback interface. And this one is also a little different. So we'll do the network command, and we'll do the loopback interface first, right? And then it's mask, right? This is the difference, right? Mask, and then it's not the wildcard mask, it's the regular mask. So it's 255, and then we'll advertise the LAN that it's in, okay? So we'll do network 192.168.5.0 mask, and then we'll do /24. And then do show run just to show you. And here it is. So we're advertising the loopback interface here, and then the network that it has, the internal network, the LAN A. And its neighbor is there, right? Let's configure this one here. Let me change this because this should be 3. And C. Let's move this to the side really quick. We'll do router, BGP, and remember, it's the ASN that the device is currently in, so 65002. We'll do neighbor, and then the IP address of the interface that's directly connected to it, right? So actually, should be better. Move this here, perfect. Right? So it's the neighbor address. So this interface right here, which would be the second address in this /30 network there. 12.12.12.2. And then remote AS, and then the ASN or autonomous system number 6500, right? And then let's advertise the loopback interface first. Mask. And then the LAN B, its internal network, let's advertise that as well. 15.0 mask /24. Do show run. And just to show you, then let's do this one. And then after we configure this one, it should pop up as the BGP being established. So conf-t router BGP, and then remember it has to be the ASN that it's in, 6500. Neighbor first. We'll do autonomous system 65001 first. So let's do this. And then the first available IP address here, see, it's one there. Mask, no, remote, and then 65. I think I added one more. See, look. Right? And then I'll show you the output, and then we'll actually test ping to see if they're able to as well. So let's do the next one. Let's just do, this should be 2. Let's just change this to 2, 2, 2. Perfect. Fast forward. It should actually show you as well. Let's go on this one. It shows you that it's up as well. just do exit, show IP route, and then BGP should be there. So it's advertising the 2, the 3, the loopback interfaces, and then BGP to this network here, right? And then show IP BGP neighbors. And then this means established right here, means that it's fully up. There's a few phases on actually how to actually do it. There's sessions. Here it is, right? This is pretty much it. It goes to idle, then to connect, to active, then open sent, and open confirm, and establishes the final phase, meaning they're fully established neighbors, right? Let's go back to the packet tracer. And then let's attempt to ping the devices over here. And I'll actually show you the ping going through BGP or the autonomous systems in simulation mode as well. 5, and I think it was 2. Double check really quick. Yeah, simulation mode, and then let's run the ping. Zoom this out a little. Let's actually see why it's got sent back. Preferences, they remove this. There we go. We just had to fast forward a little. And then this one's going to send to there. Boom. And it's going to be sent to this one there. Forward ARP. These are going to drop it. This one's going to accept it. It's going to be sent back. Right. Fast forward a little, and then we'll see it. Whoops. See, it's able to communicate across different autonomous systems, right? And that's pretty much all for today, guys. Thank you for tuning in, and see you in the next one. Bye.